arithmetic or sequence and series, arithmetic series. Type 4, t of n is equal to s of n minus s of n minus 1. So in this example here, if we look at any arithmetic series, we have term 1 plus term 2 plus term 3 plus term 4 and so on. So if I was to look at S1, what that means is the sum of the first term. So it would just be T1, which is A. If I look at S2, well, S2 means the sum of the first two terms. So term 1 plus term 2. Now, if I wanted to know what S2 minus S1 was, well, S2 is T1 plus T2. S1 is T1. So if I subtract the sum of the first two terms from the sum of the first term, I end up with the second term. The same could be said if I got the sum of the first three terms. Well, the sum of the first three terms is term 1 plus term 2 plus term 3. And therefore, if I got the sum of the first three terms minus the sum of the first two terms, well, the sum of the first three terms is term 1 plus term 2 plus term 3 all added together. The sum of the first two terms is term 1 plus term 2 added together. And therefore, if I get rid of my brackets, I end up with T1 plus T2 plus T3 minus term 1 minus term 2, which leaves me with term 3. So in other words, the sum of the first three terms minus the sum of the first two terms gives me the third term. So in general, what we say is that if I get the sum of any number of terms minus the sum of the previous number of terms, and I subtract them, then I will end up with T of n. So for example, we could be given the equation for a sum to n terms of an arithmetic series and asked to simply find common difference and the first term, so finding A and D. So if we wanted to find A, well, we know A is the first term in any arithmetic series, but that's also the sum of the first term. So that means if I let n equal 1, then I get S of 1 is equal to 2 times 1 squared plus 1. So in other words, S of 1 is 2 plus 1, which is 3. So in other words, the first term in my arithmetic series here is 3. If I want to find the second term and then the common difference, well, I'll need to get S of 2. So therefore that means that I'm going to let n equal 2. So S of 2 means wherever there's an n, I'm now going to put 2 into my equation. So I get 2 squared, which is 4 times 2, which is 8, plus 2, which is 10. So that means the sum of the first two terms is 10. But we have to remember that the sum of the first two terms means term 1 plus term 2. So therefore, if I want the second term, term 2, I must get the sum of the first two terms minus the sum of the first term, and that will allow me to find term 2. So the sum of the first two terms is 10. The sum of the first term is 3. Therefore, the second term in my arithmetic series is 7. So therefore, if I look at term 1 and I subtract it from term 2, well, that will give me my common difference, because the common difference is the difference between any two consecutive terms. So therefore I can say my common difference must be 7 minus 3, which is 4. So So in the second example here, we're given the sum of the first n terms of an arithmetic series is given by s of n is equal to n times 3n plus 1 over 2. We have to find the first term and we have to find the eighth term. And it gives us a hint by saying find S8 and find S7. So we know that our first term is going to be the sum of the first terms. So that means I'm going to let n equal 1 in my given equation. So that means that S of 1 is equal to 1 times 3 times 1 plus 1 all over 2. Making sure you're doing inside the brackets first there. So we have 3 times 1 is 3 plus 1 is 4 times 1 is 4 all over 2. So the sum of the first term is 2. In other words, A, my first term, is 2. The second part of the equation then says by calculating S8 and S7, find T of 8. And that's because T of 8 will be the difference between S8 and S7. So if we find S of 8, that means wherever there's an n, I'm going to put 8. So that gives me S of 8 is equal to 8 times 3 times 8 is 24 and 1 is 25 all over 2. So we have 8 times 25 all over 2 goes in 100 times. And then if I do the same for S of 7, well, we have 7 times 3 times 7 plus 1 all over 2. So we're going to have 7 times 3 times 7 is 21 and 1 is 22. Divided by 2, so we get 11 times 7, which is 77. So therefore we can say the eighth term is the difference between the sum of the 8 terms and the sum of the first 7 terms, which gives us term 8 is 23. So on the sheet marked T of n is equal to Sn minus Sn minus 1, which was uploaded the last day, you're going to do question 1 and question 7. So we're going to look at type 5, which is our sigma notation. And really this is mainly important for when we're doing proof by induction and doing type 1, which we would have seen at the end of last year. Because we have to be able to write out a given series when it's in sigma form. So sigma is the capital Greek letter, and it is used for summing. So when we see that symbol, it tends to mean sum of. So if we were given, for instance, this symbol here, what that basically means is we're getting the sum of the terms, where T of n is our general term, starting at or equals 1 and ending at n. So in other words, what that means is we would be getting, instead of an or, we would be putting in, so sometimes we see this as T or, I should say, really. So T or Tn. So we'd be replacing or with 1, then 2, then 3, all the way down to n. And then we'd be adding them all up together. So for example, we could be asked to evaluate, so say 1, evaluate this. So if I sub in for or equals 1, that would be 2 times 1 plus 1. So that would be my first term. Then my second term would be 2 times 2 plus 1. My third term would be 2 times 3 plus 1. My fourth term would be 2 times 4 plus 1. My fifth term, 2 times 5 plus 1. And I go all the way to the last one, which is the sixth term, because at the top we had the number 6. So this is where I'm ending, this is where I'm starting. So if I simplify that, what that gives me is 2 times 1, which is 2, plus 1, which is 3. 2 times 2 is 4, plus 1 is 5. 2 plus 3 is 6, plus 1 is 7, 8, 9, 10, 11, 12, 13. So we can see it's the sum of the first 6 odd numbers. And therefore, if I sum that up, my total is 48. A less common kind of question would be if we were to ask to write it in sigma notation. So if I look at each of those terms, if I was to write above them term 1, term 2, term 3, term 4, this would be term n. We'd need to know how many terms are there in this sequence. So we have A is 4, D would be the difference between the first and the second term, which would be 8 minus 4, which is 4. That means that my general term would be given by A plus n minus 1 times D from our maths tables. And then if I sub in for A and D, that would give me 4 plus 4n minus 4. So in other words, it would just be 4n. So in other words, our sequence is multiples of 4. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and so on. And therefore we could say, well, what term is 124? So in other words, 4 of n is my general term. And if I divide across by 4, I can see there are 31 terms in this series. So therefore, if we were writing it in sigma form, it would be the sum of ending at 31, starting at 1, and my general term is 4n. So 4 is generally the way we would see it written. And that would be equal to 4 plus 8 plus 12 plus 16 all the way down to 124. So as I said, less common in this form, more common for proof by induction is to be able to write out the first couple of terms by reading our sigma notation. So I'm only going to give you 2 questions from the sheet marked find n and s of n. So it's marked as exercise 4.3 on the top of the sheet. And I've done 1 there. So you're going to do question 2 and question 3 and question 5. Okay. So type 6 is where we're given our questions in context, so word problems. So if we look at question 6 on page 208 as our example, we have on the 1st of January 2015, John opens a bank account and deposits €100 into the account. On the 1st of February 2015, he deposits 105 in the account. He plans to make deposits on the 1st of every month, increasing the amount of the deposit by €5 each month. How much will John deposit on the 1st of December 2019? And then in part 2, in total, how much will John have deposited by the end of December 2019? So our first term is how much he's deposited on the very 1st of January, which is €100. And then we know that the common difference is that each month it's going to increase by €5. So our common difference will be €5. So on the 1st of December 2019, well, how many terms has going to have passed? In other words, what is n going to be equal to? So if we think about the 1st of January 2015, to the 1st of December 2015, well, that would be 12 deposits. And then we'd have 2016, 2017, 2018, 2019. So we would have, again, 12 deposits, 12 deposits, 12 deposits, and 12 deposits. So therefore, in total, we would have 5 years of 12 deposits, which is 60 deposits. So what that means is that n would be equal to 60 for the 1st of December 2019. And we want to know, well, what's he putting into the account on that day. So therefore we're looking for what term does that represent. So because we know it's arithmetic, it's increasing by a fixed amount each time, we can use t of n is equal to a plus n minus 1 times d. And therefore, if I look for the 60th term, well, a is 100, n is 60 minus 1 times d is 5. So we have 100 plus 59 times 5, which gives us €395. So in other words, on the 1st of December 2019, John will deposit €395 into his account. So part 2 then says, what's the total? So because we're looking for the total amount of money deposited, then what we're looking for is, what is it summing to? Again, it's arithmetic. So it's 2a plus n minus 1 times d. And it says by the end of December 2019, how much will he have? So we're adding all of those first 60 terms. So it's the sum of the first 60 terms, which means n is 60. A, we said, was 100 and d was 5. And therefore we get 30 times 200 plus 59 times 5. So therefore the sum of the first 60 terms is 14,850. So by the end of December in 2019, you would have a total savings of 14,850. So I'm going to get you to do question 7 and question 11 on page 208.